Today we're going to look at the surface area of prisms and cylinders. Kind of starting a new chapter here, and this will be the last chapter for the semester, so last chapter for geometry for a lot of you. So moving forward, surface area, look to find the lateral area, total area, and volume of a right prism with a square or rectangular base. So again, like I said, we'll get into 3D shapes. We already dealt with a little bit with the 3D shapes, making the kites earlier in the year. Some of them are still hanging from the ceiling, but those are the 3D shapes. Those are pyramids. We'll get into those after Thanksgiving break. But 3D figures. So what they are, they're polyhedrons. That's kind of the formal name for what they are. The polyhedron is a solid with flat surfaces, as you can read there, and encloses a single region of space. They're polygons, and these are shapes. We've spent a lot of time with the polygons back with the quadrilateral chapter. But the first thing we're going to look at, the first solid we're going to look at, is going to be a prism. So there's what a prism is. There's a formal definition of what a prism is. Polyhedron with two parallel congruent faces called bases. The other faces are parallelograms. So again, a lot of what we have dealt with before, and now we're going to combine it into the 3D shapes. So prisms, you can see there, they're named by what their bases are. You can see there at the end. So whatever their base is, that's what is going to give the name of the prism. So the base, again, you can see there, the base is, they're parallel planes, and they're congruent polygons. So they're congruent to each other. Think a lot of times the top and the bottom. So the top and the bottom are both the bases. They're both congruent to each other. If you think of moving along real quick, getting more into the prisms and the rectangular prisms. The lateral faces, we have the bases are the top and the bottom. The lateral faces are the ones that aren't the bases. A lot of rhyming words here, but lateral faces are the ones that are not the bases. So if the bases are the top and the bottom, the lateral faces, as you can see here, are all around the sides. So base, top and bottom, lateral face, all around the sides. The faces, they connect the two bases. Those segments are called the lateral edge. So we have the lateral edge is this segment right here, and we have the lateral face, which is the whole. So I'll highlight here. Here is the lateral edge, and then the lateral face is this whole side that connects the two bases. So lateral face and then the lateral edge go together. Those are all on the side. And altitude, that's going to be the same as, again, we're dealing with the right prism. We'll only deal with right prisms. But if the altitude and the lateral edge are the same segment, then it's a right prism. So that'll be always the case for us. This is a right rectangular prism. I know it looks kind of like a square, but that's just the figure that I could find. So a right rectangular prism, think of a Kleenex box, or a kind of a big box of paper, or a lot of probably the Amazon boxes that show up your houses. Those are all right rectangular prisms. So again, the base named off the bottom and top, the base is a rectangle, so they would be right rectangular prisms. So a couple different things. The altitude, the length of the altitude, I'm sorry, is the height. So we have the height of the prism, that is the height there. The lateral area, that's going to be the area around the sides. So again, we talked about lateral faces being all the figures around the sides. The lateral edge being the segments on the sides that join the bases. So the lateral area is going to be the sum of the area of the lateral faces. It would take a while to add all those up. So if we went around, and again I'll highlight this. Here's one lateral face, so we'd have to take the area of that lateral face and then add it up to the area of this lateral face and add it up to the one back here and the one over here. That would take some time. So we want to make sure we're as efficient as possible, use our time as best we can. And so we're going to come up with, we have a formula we're going to use, a theorem. The lateral area of a right prism equals the perimeter of the base times the height. So again, LA, that means lateral area. I'll write it all out for you. LA equals lateral area. P equals the perimeter of the base. and h is the height of the prism. So P is the perimeter of the base, h is the height of the whole prism. So all the way from top to bottom, that's the height of the prism. The total area, we call this, or is also known as surface area, and a lot of times you'll hear that, and the same thing. That's everywhere. That's the area of everywhere. So I'm going to go back 2 slides here. So again, these are all the lateral faces, and then if we would add in the top and the bottom, here's the top, and then the bottom, adding up every area of all the sides, top and bottom, left, right, all around, that would be the total area, we call it, or the surface area. We have a theorem that goes along with that. That's going to be the total area is going to equal the lateral area plus 2 times big B. Big B is the area of the base. So I'll write everything out for you here. So TA, that is the total area. LA is still lateral area. So the same lateral area formula from the previous slide, that's how we find the lateral area. So that's going to be important when we're determining the total area. And then big B is the area, let's call it area, there we go, area of the base. So those are important things. The big B, TA, and LA, that's an important part. That's what we'll be looking for in the examples coming up here in a second. The last thing we'll look for is the volume. The volume, as I talked about earlier, that's going to be the space inside the prism. So I talked about a rectangular prism. Think of a Kleenex box. The volume is how many Kleenexes are in the box. So how much space, that's the space inside. Space enclosed by a 3D figure, again, polyhedron 3D figures that we're dealing with. So the theorem there, the volume of a right prism equals the area of the base times the height of the prism. So we have 3 formulas. So the first one is the lateral area, the second one is the total area, this one is the volume. So V equals volume. Big B is still the same, that is the area of the base. And H is still the same, that is still the height of the prism. So those are all we're looking at. We're going to come up with, in this first example, you'll see what I mean. So lateral area, total area, and volume of this right rectangular prism. So before we find all that, we need what I'm going to call key information. So this will help us find everything. So the key information is always going to be the same thing. We're going to say it's the perimeter of the base, the height of the prism, and the area of the base. So those 3 things are going to be our key information for these right rectangular prisms. So I'm going to say this down here, again, I'll highlight this. Here is what I consider the base. There's one of the bases, and up top, here's the other base. So those are my bases. So let's go off what we know. This is a rectangle. So I know if this is 4 right here, opposite sides of a rectangular congruent, so that's 4 there. If this is 9 right here, over this side right here is 9. That's going to be helpful in finding the first piece of my key information, the perimeter. So a perimeter, I'm just going to add up all the sides. So 9 plus 9 plus 4 plus 4. So the perimeter is going to be 9 plus 9 is 18. 18 plus 4 is 22. 22 plus 4 is 26, and this is centimeters. The height of the prism, again, that connects the 2 bases, goes between the 2 bases. So that's given to you. That's 9 centimeters. Nothing to do to find that. But the area of the base, again, this is a rectangle, so I'm going to take 9 times 4. 9 times 4 is 36, and that's area, so that's centimeters squared. So once I get into have my key information, I can get into the lateral area, total area, and volume. So lateral area, again, I'll remind you, is going to be the perimeter times the height. So again, based off what we have here, this is going to equal the perimeter, 26, times the height, which is, again, you can see there it's 9. So 26 times 9, using your calculator, is going to be 234. This is area, so that's centimeters squared. Now the total area, I need to use the lateral area. So total area equals LA plus 2 times big B. Lateral area is 234 plus 2 times big B. Big B from up here, again, from our key information, is 36. Total area equals 234. 2 times 36 with your calculator, that's going to be 72. So the total area, again, still talking about area here, is going to be 306. Area is centimeters squared. Now last for the volume. Volume is going to be a little different. Volume is going to be big B times the height. So here, big B, again from key information, 36, times the height, which is 9. And look at what this is. This is centimeters squared. I'm going to write this in here just for this first time. Centimeters squared times 9 centimeters. So I'm going to use my calculator. 36 times 9 ends up being 324. We know it's going to be centimeters, but I have squared centimeters here and another centimeter here, so that's going to give me centimeters cubed, centimeters to the third power overall. So make sure volume will always be centimeters cubed. So my final answers, again, my lateral area is 234 centimeters squared. My total area is 306 centimeters squared, and my volume is 324 centimeters cubed. Again, that's the big difference from the area and volume. Volume is cubed. Now this one's a little different. You can look here. I give you the lateral area. Given the lateral area. So before we found the lateral area, now I've given that to you. So LA equals 400 centimeters squared. So let's go again. This is a rectangle. Here's my base. I'll outline it in blue again. There's my base. So knowing this is a rectangle, this has to be 15 over here. Well, that doesn't help us find the other side, but this right here is the height. So what I can do here, I'll use my lateral area formula. LA equals perimeter times the height. So let's list our key information. We'll do perimeter. I'll label this. Perimeter, height, area of the base. Again, a lot of times the height will be given to you. The height in our case is 8, so in centimeters. So here's my formula. I have my height. That tells me I can find the perimeter. So I'm going to use my formula, 400 equals the perimeter. I don't know what P is. That's perimeter times 8. So now I can solve for what the perimeter is. So I'm going to divide each of these sides by 8. And I get P. 400 divided by 8 using your calculator is 50 centimeters. Good. Go ahead and fill that in your key info here. But now I know if this is 50, again, we know back to our quadrilateral rules, if this is 15 and 15 is 30. If the whole perimeter is 50 centimeters, 50 minus 30 gives me 20 left. I have 20 left between two sides, this side up here and this side down here. So 20 divided by 2, sorry, getting a little small and messy over there. Each side here is 10. So now I can find the area, big B, area of the base. Area of the base is 10 times 15. 10 times 15 is 150 centimeters squared. Once I find that, I can find the two missing things, what we're looking for. Total area and volume. So total area equals the lateral area, 400, that was given to us, plus 2 times the area of the base. Area of the base is 150. Total area equals 400. 2 times 150 is 300. Total area equals 700 centimeters squared. Volume equals area of the base, 150, times the height, again, height's right here, is 8, Use your calculator. 150 times 8 gives you 1,200. This is times here. 1,200 is volume, so it is centimeters. 3 didn't show up. Centimeters cubed. So again, area is my final answer. We were given the lateral area of 400, so the total area is 700 centimeters squared. The volume is 1,200 centimeters cubed. One last quick example. A regular prism, we've talked a lot about regular figures. All the angles and all the sides are the same. So a regular prism that we'll deal with is a cube. Think of like a die playing a game. A die is a regular prism. So lateral area, total area, and volume of all the sides are 7 inches. So again, perimeter, there are 4 of them. 4 times 7 would be 28 inches. The height that's given to us, that's 7 inches. Again, everything's 7. Area of the base, 7 times 7. I'll write that out for you. It's 49 inches squared. So now lateral area equals perimeter times the height. Perimeter is 28. Height is 7. Lateral area, gives you, using your calculator as always, 196. 28 times 7 is 196 inches squared. Total area, LA plus 2 times the area of the base. So lateral area is 196 plus 2 times the area of the base is 49. So I'm going to go ahead and add the 196 plus 2 times 49 is 98. Total area is 294 inches squared. One last time with the volume equals the area of the base times the height. Volume equals area of the base is 49. Height is 7. That's going to end up equaling 343 inches cubed. So again, my answer is lateral area 196 inches squared. Total area is 294 inches squared. Volume is 343 inches squared. That's all for today with prisms. We'll pick up cones tomorrow.